If you're at the point where you've got the hang of writing numbers in standard form and converting back to ordinary form and you're ready to advance to the next level, then today we're going to look at calculating with values written in standard form. If you want to answer some of the questions in this lesson today, then you will need something to write with and on, and having a calculator to help you out is optional. I'm going to jump right in, so if you need a little bit longer to read the task board, pause the video now and hit play when you're ready. I'm going to give you a very brief recap here, but if you've not already seen my video on standard form and you need to go ahead and master that first, please do that now, because that contains skills you will need to be able to proceed with this lesson. This is just a very quick recap, so hopefully what we already know is that standard form is a way to represent numbers using powers of 10, and the general form is a times 10 to the power of b, where a is between 1 and 10, not inclusive of 10, and b has to be an integer. That's a whole number and it can be positive or negative. And just to check you are okay with the skill of converting between standard form and ordinary form, here are 4 questions for you to have a go at. Pause the video now so you can give them a go and then hit play when you're ready to see the answers. Okay, if we are converting 42,500 to standard form, we're going to write non-zero digits as a decimal between 1 and 10 and work out what power of 10 we have to multiply this by to get the original number. We'd have to multiply this by 10,000, so that would be 10 to the power of 4. This next one we are writing in ordinary form, so I'm going to begin by writing down my digits without the decimal point. I acknowledge that I need 7 digits after the first. I've already got 2, and so I need 5 zeros. And if you wish to put commas in, just to make that clearer for you, 37,200,000. In this next one we are writing in the standard form. It's a very small number, which tells me my power of 10 will be negative. I can't write this one as a decimal because I've only got the singular digit 2, so it's just 2 times 10 to the power of negative, and I've got 1, 2, 3, 4, 5, 6 zeros. So 2 times 10 to the power of negative 6. And our last one, converting back to ordinary form, the negative 5 tells me there are 5 zeros at the beginning, including the one at the start, followed by my 6, 5. Check your answers for those. If you're happy and got them right, you are ready to proceed in this lesson. If not, you might want to go back and watch my previous video on standard form until you're confident with this skill. Okay, so with addition and subtraction, we are going to convert our standard form numbers into ordinary form, add or subtract them, and then convert them back. Obviously, this will be a much easier process if you have a calculator, but there's a good chance this will be on a non-calculator paper, particularly if the values aren't that difficult to work with. But there's no harm in having a calculator nearby to check your answers, or if you come across any parts of the calculation that you find too difficult. And I'm looking at my 2 values here. I'm actually going to start with the larger one, which is the one which is to the power of 6. The larger power of 10 will give it away, just because it's easier to line up my place value columns when I've got the bigger one first. So we've got 2,230,000 as our first number, and our second number will just be 49,000. So then I can see quite clearly where to align those. And then we're going to add them up. 0, 0, 0, 9, 7, 2, 2. Now, depending on what values you get on your powers of 10, you might just be able to merge them together and see what the answer will be. Some people prefer to have it written down just so it's absolutely clear. So we've converted both numbers into ordinary form and added them together, and then we're going to convert them back into standard form. So that would be 2.279 times 10 to the power of 6. So as I just said, some of you may be able to see that that 4 would have combined with that 3 because of place value without writing it down, but I think it's always better to write it down just so you can see it clearly. Here are 2 for you to have a go at. One is addition and one is subtraction. So just be careful that you get the right operation. And I'm going to advise you write something down to see if you can get the right answer, and pause the video now because I'll be going straight through the answers, and hit play when you're ready. So I've got 1,405,000 as my bigger number, and then I've got 783,000 as my smaller number, and we are adding. So we've got 0, 0, 0, 8, 8, 11, carry the 1 gives us 2. which if we convert back, that'll be 2.188 times 10 to the power of 6. And onto your second question, obviously we have to put the first value first, regardless of the size of the power of 10, because it's subtraction and the order matters. So we've got 89,500, and we are taking away just 380. 0 take 0 is 0. 0 take 8 I can't do, so I'm going to come in and borrow. 4 take 3 is 1, and then we've got the 9 and the 8. So if I convert that back to standard form, we've got 8.912, I'm just going to squeeze this in here, times 10 to the power of 4. Another set of addition and subtraction questions now. However, these ones have got negative powers of 10, but it doesn't change the way we approach the question. That -2 tells me I've got 2 zeros at the start of my number. And when lining these ones up for our place value, make sure you line up the decimal points. So 0 point, this one's got 3 zeros altogether, 4, 1. And if you don't have the same number of decimal places, you can just add on as many placeholders as you need if you prefer to do it that way. And then we're just going to add. 6 add 1 is 7, 5 add 4 is 9, 7 add 0 is 7, and the rest are zeros, which if we convert this back to standard form, will get us 7.97 times 10 to the -2, because my answer has 2 zeros. Here's 2 more questions for you to have a go at. Pause the video and hit play when you're ready to see the answers. So we have got 0.00065 and 0.0000736. You may have seen, if you're quite confident with your place values, how these two could have just slotted together, but it's always good practice to write down the working out in full. And remember what I said, if you do feel more comfortable adding these placeholders in so they have the same amount of decimal places, that's absolutely fine, you can go ahead and do that. Not essential if you don't need to. And so if I run along, adding these together, we get an answer of 6.5736 times 10 to the power of -4. And with this one, we've got 0.0865 minus 0.00027. With subtraction, I always advise putting placeholders in just to make it a bit easier. Now we can see when we go to do 0 subtract 7, we can't do that, and there's nothing next door to borrow from. So we're going to bring this 4 and make this a 10, but then we're going to take that 10 and make that a 9. Now I've got 10 take away 7, which is 3, 9 take away 2, which is 7, 4 take away 0, and the rest are then just take away 0. Which gives us an answer of 8.6473 times 10 to the -2. And then we move on to multiplication, which if you know your laws of indices, and I do have a video on that if you don't, this one will take less effort. You don't have to write as much down. What we're going to do is we're going to multiply these values up front and multiply our powers of 10. So I'll do 1.2 times 4, which is 4.8. And when I multiply my powers of 10 and I apply my multiplication law of indices, 10 at the base stays the same and I add the powers. So 4 add 6 is 10. So notice, no working out required. I went straight from question to answer. There's only one time when you'll need to do a bit of working, and I'll show you in this next question. So if we do 3.5 times 6, that's 21. And then if we use our multiplication law on the powers of 10, we get 10 to the power of 5. That might seem straightforward enough. Also, when I talked about potentially needing a calculator, you may have needed one to do 3.5 times 6. That's the sort of time in today's lesson where you might require one. There's a problem with this answer though. 21 times 10 to the 5 is not correct standard form because the 21 is greater than 10. Just a reminder that our standard form should be written like this, where A is between 1 and 10. 21 doesn't fit that. So then we do an adjustment. If I want to bring this down to a value between 1 and 10, I can use 2.1. I've had to divide by 10. But that means I've changed the value of this number written in standard form. I've made it 10 times smaller. So to balance it out on the power of 10, I make it 10 times bigger. If I've got 10 to the power of 5 and I multiply that by another 10, that would become 10 to the power of 6. So the power just increases by 1. So 21 times 10 to the power of 5 is the correct value, but it isn't written in standard form. So we adjust it so that it is written in standard form. Here are two for you to have a go at. Pause the video now and hit play when you're ready to see the answers. 1.5 times 3 is 4.5 times 10. And when we add our powers, we get 12. So 4.5 times 10 to the 12. 2.4 times 5 is going to get us 12. Times 10 to the power of 8 plus negative 2 is 6. But we do have to adjust this one. So if I've divided this side by 10, I'll have to make sure I multiply this side by 10, increasing my power to 10 to the power of 7. And for division, we do the exact same thing, except we divide. So 8.4 divided by 2.1 is 4. And my division law tells me to subtract the powers, so 11 take away 6 is 5, so that would be 10 to the power of 5. 3.5 divided by 7 is 0.5. Subtracting my powers, 3 minus negative 2, well that's 3. Subtract a negative is like adding, so that would be positive 5. And once again, I'm not in correct standard form. This is less than 1, so I need to multiply it by 10 to make it 5, which means I'll need to divide this by 10 or reduce that power by 1 to make the answer correct. So 5 times 10 to the 4. Two more questions for you to have a go at. Pause the video now and hit play when you're ready to see the answers. 3.9 divided by 1.3 is 3. And subtracting those powers also gives me 3. So 3 times 10 cubed, or 3 times 10 to the power of 3. 4.8 divided by 8 is 0.6. 2 subtract 6 is negative 4, and we need to adjust this again because it's not quite in standard form. So if I times this side by 10 to get 6, I'll have to divide this side by 10, meaning I need to reduce this power by 1, which would be negative 5. On to some multiple choice questions now. I will pop a 30-second timer on for these to give you a chance to write something down and work them out. But if the timer doesn't work for you, feel free to just pause the video as we go along and use the amount of time you need. Here are your options for this first one. If you said C, you would be correct. Here's another one. If you said B, that's correct. Another one. If you said A, that's correct. And one more. And that one was D. Finally, for a bit of independent practice, just so you can check that those skills are strong for you, if you pause the video now, when you hit play, I'll pop the answers on the screen. And here are the answers for those questions. So go back through and check those. If there's anything you're unsure about, you can go back and watch the examples again, or ask us down in the comments. We do try to answer all of the questions related to the content of the video. And all that's left to be said is well done for taking part in this video lesson today. Every bit of revision you do will do you service and benefit you when it comes to sitting your exams. So do give yourself credit for all the extra work you put in. Remember to like the video and subscribe for more video lessons, and if you also enjoy short form content like revision, quizzes and tips, you can also find us over on TikTok and Instagram. I'm Charlotte, thank you for watching this video.